The broadcast is now starting. All attendees are in listen-only mode.
My name is Brian Kading, and I'm here with Mr. Bogdan Vesfamilny. Amit may be joining us later for the presentation, but we'll go ahead and get started. So this is just an overview on the Red Hen Systems PipeEye service. We take a dual approach when we do our methane detection surveys, whether we do them from air or from the ground. We take a quantitative and an observational approach. Our quantitative side, for our quantitative side, we use a Boreal Laser. What that does is that gives us PPM readings as we fly or drive the pipeline. And then the observational side, we use a FLIR infrared camera, and we also take 4K video or other video. We also take color video as well. So that's our observational side. What that helps us do is that helps us eliminate any false positives. It helps keep us from missing plumes or emissions points while we're doing the survey. And so it helps us catch more stuff, and then it helps us verify emissions we do find. So, next slide. So the Boreal Printer has a tunable threshold alarm, and that threshold is set at 10 ppm. Whenever we find an emission, whenever the Boreal detects an emission that is over 10 parts per million, that alarm goes off. Our Gasware software is our real-time data collection and reporting software. So what that does for us is it tells us the PPM levels as we're flying or driving the pipeline corridor. And then our Gas Analyst software, that's our post-process software. That is a proprietary software. To what that does is that helps us to find the origination points of the PPMs that we pick up on the survey in the post-process. So what we do there is we're taking the atmospheric data, like the wind speed and direction, the temperature and humidity, and plugging that information into our gas analyzer software. And what that's doing is that's helping us to locate where those emissions originate from. And then we back up all the data and make it available on our secure network to our customers. So the Boreal Gas Finder AB is a open path tunable diode laser. It reads methane levels as low as 0.2 parts per million. What that does is that allows us to establish an ambient level as we're doing the survey, and then we can see where the points are that are above ambient level. So the Boreal is also tunable to 4 other gases: H2S, hydrogen fluoride, ammonia, and carbon dioxide. However, we have only ever used it to detect methane. So then we also use a FLIR camera. The FLIR camera that we use is an A6788SC. The important thing to know about that is the resolution on that camera is 640 by 512, which is double the resolution of your commonly known GF320, which is only a 320 by 280 resolution. That resolution allows us to view plumes from 150 feet above ground level, or basically it allows us to view the plumes as we're flying the pipeline. And also this camera is set up as it's a mid-wave infrared camera, and what that means is it's specifically designed for optical gas imaging, which means it's designed to help us see the plumes. This is just a picture of a plume that we picked up using our FLIR camera. And then when we go to the color video side of things, like I said, we typically fly with 4K video. However, that creates larger files. If a customer wants smaller files, then they can get away with 720p or 1280p video. We can take a video that's a lower resolution, and that'll give our customer a smaller file, or we have the ability to go up to 4K video. So this is just an overview of kind of what it looks like. You've got the helicopter flying in the corridor. Helicopter is going to have that Boreal laser on it. We're going to be running the infrared camera, so the laser is going to pick up the plume, the camera is going to see the plume, And then basically phase 2 of the survey would be the guy on the ground finding the origination point of the emission. This is a picture of Bog flying in a helicopter. And as you can see, we've got the Boreal mounted under the helicopter. We've got our anemometer attached to the Boreal. And we've got Bog holding and operating the FLIR camera. If you look at, where the anemometer is, it's not going to get a perfect reading based on where it is on the helicopter, but it's going to give us kind of a reference point, and it's going to give us relative wind speed, and then it's going to give us wind direction as well. So this is kind of what a helicopter setup looks like that we use to fly pipelines. And then here we've got a vehicle in the upper right corner of the slide, and we've got a utility terrain vehicle in the lower left of the slide. So we can mount the Boreal to a vehicle or to a UTV, as well as other sensors, and then we can run color video, we can run IR cameras, and we can do all this from the ground as well. It's typically the most efficient to do it flying, but this is just to let you know that we do have other options available. So when it comes to data analytics and hosting, this is where we shine. This is, what we're good at is analyzing your data and making it make sense for you. We've been in business for about 20 years, and we've never had any security breaches, so we keep your data accurate and secure, and we get it to you in a timely manner. And then as far as training goes, we don't want our customers to just buy a Boreal or purchase equipment or here's your report and good luck reading it. We have a friendly, knowledgeable staff to help folks. We will show you how to download your reports, how to reference different parts of your reports. We also give our customers a summary report with an overview of all the problem areas and locations where they can find problems. So there's 4 different ways that our clients can work with us. They can purchase all the equipment and find someone to fly the helicopter or or they can put it on a vehicle and drive their pipelines, and then we can analyze their data for them. They can purchase the equipment on a lease-to-own contract, and then we can process the data for them. They can rent equipment from us, and options 2 and 3, basically those 2 options, the operator would be contracting the pilot on their own or be using one of their vehicles to drive the pipeline. And then in either of these options, the operator would have the option to have Bog or one of our engineers fly with the pilot or drive with the vehicle and operate the equipment, or not. They can operate the equipment themselves. And then in all 4 of these options, we're always processing the data and making it make sense for the customer. And then number 4 is the most common, the full service option. And what we're doing there is we're contracting the helicopter pilot, we're providing the equipment, we're processing the data, we're doing everything A to Z. So just wanted to go through those options with how our customers can work with us. And then if you have any questions, this is our contact information, our emails, and our phone number here at the office for after the presentation. And then do you want to take some questions now, Bog, or do you want to go through some?
Yeah, let me sort of look through what you guys have so far now.
Okay. So is the detection by the 3.7 micron or methane absorption line? Can you detect methane by LiDAR? You want to take that one?
Sure. LiDAR is a little different from what we usually do. LiDAR is essentially your scatter system that averages out readings based on the reflection. LiDAR, in our particular case, is not the best sort of way of doing this kind of patrols. The reason why is there are a lot of issues with absorption with smooth surfaces like water, and a lot of the signal gets sort of absorbed by the ground as well. So LiDAR is something that we don't tend to do, but it's something that we always wanted to try. But you know, we are mostly focused on this idea of LDAR, which is leak detection and repair. So it's a little different. Will the slides be available later?
Yes.
Sure, we can post the slides, no big deal.
We'll actually post the entire webinar to our website for access later.
Do you
yes,
fly?
Do we fly in urban areas? Yes, we do. Can you detect methane and CO2 in the PPM range?
The answer is yes. They're pretty much all the way concentration is measured is essentially in parts per billion, parts per million, or milligrams per cubic meter. The Boreal laser that we're using is tunable for CO2, just like we mentioned on the slides. But it seems like the industry sort of kind of diverged a little bit from CO2, and they are mostly focusing on methane. So we've been doing a lot more work on methane than on CO2. But yes, that can be.
The other thing about carbon dioxide is, you know, it's pretty hard because you have quite a bit higher ambient level of that in the air. What's nice about methane, doing an aerial survey, is methane's lighter than air, so it's going to go up, and you're going to be able to establish a pretty low ambient level of parts per million on methane and then see some major differences. Where with CO2, I don't know that you would be able to necessarily do that.
As far as we also get a lot of questions in terms of CO2 and methane being detected at the same time, using our current combustible gas analyzer, which is Boreal, that is not available. But however, Picaro, for instance, Picaro surveyors, they do keep track of methane and CO2 sort of at the same time. Just like I mentioned, like Brian mentioned, we're not really married to one, you know, combustible gas analyzer, fugitive gas analyzer, if you will. So we work with wide array of different equipment. So, you know, perfect example, we worked with Picaro before. So.
So the next question is, LiDAR is single channel, but imaging by FLIR, I'm not sure I understand that one.
So just kind of like, I'm not sure what the question is, but I think I kind of got an idea of what you might be asking.
And Carl, if you can kind of clarify that for us by maybe asking another clarification question.
Yeah, it seems like something got misspelled, but basically what we use our combustible gas analyzers for is to kind of get an idea for where we need to be looking, and then we pretty much zero in on that specific spot or that specific area of interest with our camera, and that way we can actually verify the emission. So it's kind of we use our Boreals or any other equipment as a precursor to our optical gas imaging camera.
So the next question is, are you taking IR camera videos the whole time, or is it just triggered due to investigations when you detect elevated methane emissions? So this is a question from Adam. And Adam, the answer is we take the IR video the entire time that we're flying. And it's kind of an either-or thing. If we pick up a higher PPM level with the Boreal, we're going to try to find the plume with our camera. The same thing is if we see a plume with our IR camera that we don't pick up with the Boreal, then we'll try to fly back and see if we can pick up a higher PPM level if we see a plume with the IR camera. But the answer is that we take IR video the entire time that we are flying.
Yeah, there's no reason for us not to do that.
Where are we headquartered? We are headquartered in Fort Collins, Colorado. See, I take the easy questions. I give Bob the hard ones. And then what size of a leak can you see from what altitude? It
depends on what kind of combustible gas analyzer we use. As far as the size, pretty much the highest I've seen was about 500 ppm. So as far as the elevation goes, we're flying, and I'm going to jump in ahead of myself. We got a question before the webinar started as far as the limitation of the system or the systems that we use. We're not flying too far from the ground. I think we did a bit of an AGL study, and we're anywhere from, depending on the terrain that we fly, anywhere from about 30 feet to about 100 feet. It really depends on the sort of the terrain that we're flying.
You know, 150 feet is the maximum, really the maximum AGL that we want to fly. And the thing is if the wind's blowing, it's just going to be a lot harder to pick up those PPMs than if the wind is not blowing. You know, so it makes a difference. Time of day, temperature, humidity, all those things factor in. But you know, as far as the size of the leak, we can see from 150 feet AGL. I mean, we can you know, 2-3 parts per million. We're going to pick that up. Like I said, if the wind is really strong, we're probably not. You know, maybe we don't pick it up because the wind is blowing too hard. But generally, with you know, under 10-mile-an-hour wind, 150 feet, I would say, you know, 3 to 5 ppm, we're going to pick that up. To answer Carl's question, can you quantify a leak rate?
The answer is, it depends what you mean by quantifying. If you were interested in essentially nothing but a concentration information, then yes. If you are talking about, you know, your flux or your rate information, that can be done. What we usually tend to do is, with our aerial survey, we're trying to identify the critical points of interest, meaning where the emissions are coming from. And then we use ground-based patrol, which is either SUV or UTV based, where we have a bit of a different equipment on board, and we use you know, essentially information about concentration as well as atmospheric information, and we use the air model to sort of back calculate the emission rate. Now, just like probably if you're asking the question, you know that, you know, flux is kind of hard to calculate and has quite a bit of intrinsic error to it. So in our best sort of case scenario, we're getting close to about 70-75% accuracy on average. So in most of the cases, our clients are satisfied with that kind of result. However, if you know, if that's not kind of the numbers you're after, the best sort of way to estimate emission, it would be high flow meter, and you kind of limit it on what kind of equipment you can use it, especially if you have buried infrastructure, you can't really do that.
So Olga, I would say the short answer is that from the air we can't really quantify the leak. Like Bog said, doing a second phase where you do a ground patrol and then try to measure the flux with a flow meter or a bag or something like that, then that would be a follow-up. But from the air, no, we can't really quantify what the flux is. So Nick has a question. Maximum of ground level, yes, is 150 feet. The maximum speed you can go, Nick asked about maximum speed, is 55 miles an hour is the maximum speed rating. We like to go about 35 to 40 miles an hour. That's kind of the sweet spot. Highest operating altitude for the system, I mean, altitude-wise, we've had it at 11,500 feet, 12,000 feet. So we can pretty much do any altitude. As far as above ground level, we don't want to be any higher than 150 feet.
Let's go.
As far as pinpointing locations, Bog's going to show you that here in a minute. And Stefan had a question about the different types of aircraft that we can put the equipment on. Yes, R-44, R-66, Bell 206, and an A-Star, we can do all those.
44, there's a specific bracket you can get. As far as the hook, you mean cargo hook? It's a little different on Robinson's. I've never done it on R44 on the hook. We have done it with the hook on Twin Star and AS350. So hook can work in some cases if we can sort of make it not too wobbly. Otherwise, it's kind of not very safe, and it can also distort some of the concentration readings.
And then continuous monitoring, that would be a ground monitoring system. Jeff had a question about continuous monitoring. Ours is, we monitor it when we fly over the pipeline, and that's it. We do have other products that we would talk about at a different time for continuous monitoring. Olga asked, does the signature actually get stronger when you're closer to the leak point? I would say the short answer is yes. We're going to pick up a better PPM value the closer we are to the emission, because it's going to be less spread out. Is gasware proprietary to Red Hen? That is yes. That's Kendall's question. And then I'm going to skip down a little bit. Is the weight of the equipment low enough to utilize a UAV? That's one of Kendall's questions. That's a great question. The answer is right now the equipment is pretty much too heavy to use a UAV. The UAV that you would have to use would be almost a full-size helicopter.
So the equipment that we use right now is specifically designed for airborne. They are smaller miniaturized versions of Boreal combustible gas analyzer, gas finder AB, that are small enough. It's about a pound and a half in weight, and just about the size of multiple computer mice. They're small enough, but you also have a bit of our not as accurate sort of PPM. I believe it starts off at 5 ppm as a sort of starting cutoff. But they are combustible gas analyzers that are made by Boreal that you can outfit your UAV with. And some of the UAVs, if you're willing to help, if you want us to help you out along the way, some of the UAVs can also be equipped with infrared cameras as well. So we can help you with your UAV system if you have any interest in that.
Okay. So Adam has a real good question that he restated. I'm going to answer that real quick, and then Bog's going to move on and show you guys some sample videos and whatnot. So he's trying to restate a question for, do we need to hover near a leak to do a source identification, or is the IR camera video done entirely at full speed? The IR camera video is done at full speed. So we do not need to hover to identify the source. It is done at full speed. That is an excellent question. So now I'm going to turn it over to Bog. He's going to go through a couple of examples for you, and then we'll answer a few more questions.
Yeah, just to kind of go back as I'm trying to set this thing up. Basically, when we're flying, we're interested in high emission sources. So when you fly, you can actually see it relatively good. However, if you have a small emission and for whatever reason you have not the best atmospheric conditions or whatnot, we tend to hover just to make sure we got 100% of it. But just like Brian said, it's not necessary, so we can see it pretty good. So what I'm going to do is I'm going to go ahead and show you sort of the data acquisition side of things. All right, so what you see here is part of our patrol videos. So in this case, we're going to be showing you some video feed from GoPro as well as Sony SteadyShot and Sony and FLIR that we use for our patrols. So I'm going to start off with the GoPro. So pretty much what you see here is our video feed from the GoPro. I'm going to try to minimize the screen a little bit so you can see the ground track a little better. So on the right-hand side, you can see the ground track log of where we at. On the left-hand side, we got our GoPro video. So in this case, we are flying in a sort of high consequence area where there's quite a few windmills as well as abandoned well pads and existing well pads. So the video is, in this case, GoPro was mounted nadir, so you're getting nadir view. So pretty much what's going on is on the right-hand side, you get your ground track log. All the points are active. You can click on any of these points. You can get the associated information about that specific point. Video time code, lat long, course of the helicopter, UTC time, altitude, speed, AGL, PPM, confidence level for that specific reading of the concentration, laser information as well as the status. The most interesting part of this is that QR code capability. Basically what can happen is that, let's say you have a manager that's working from the headquarters, he can take a picture with his cell phone and essentially get the information about that specific point. For instance, if it's a high alarm point or you have a high emission in that specific point, the technical sort of supervisor can share that information on the fly with his ground crew, and the ground crew will get the directions on where to go to fix that specific emission problem. The other thing is we can operate the video from the ground track as well as from the seek bar here at the Windows Media Player. Just like you saw, push the button and then move the video cursor to that specific point. We can also do the same thing from our Windows Media Player, so you can see the cursor move to that specific location. So the same thing here again. We can skip around every time you have a moving cursor. Will also display the VTC time, which is video time code, so you can get a better idea of where you're at on your video. So this is just the GoPro view of it. We also tend to capture frontal video as well as FLIR. Frontal is also used for other purposes such as population density, surveys, and just in general see if any obstructions are ahead of the helicopter path, such as power lines, canopies, things like that. We also use a combination of nadir and frontal view to look for anything that has to do with vegetation, dead vegetation, encroachments, things of that nature as part of our survey as well. So I'm going to go ahead and switch to Sony Steady Shots, which is going to provide us a bit of a frontal view. And they're a bit of a modified Steady Shots. They're not your conventional. They come with mechanical lens that will narrow down the field of view. Because the problem that we have, for instance, with GoPro is the idea of a fisheye effect, meaning that you get a bit of a distortion on the ends of your video, on your corners of your video. So that's why we have to get a bit of a narrower view camera feed. So I'm going to go ahead and switch to FLIR. I think a lot of you are interested in how FLIR is operating and what it can provide. So here's the view from the FLIR camera, just like Brian mentioned, 640 by 512, resolution. The interesting part about the FLIR is that what you see is essentially raw video. Here's a good example of the abandoned well pad. It was sealed. We saw absolutely zero emission coming out of that. But the interesting part about the FLIR is that we can essentially, if we see something, it's identified as an emission at that point. The video we're showing you is sort of raw. Usually when we supply videos to our customers at the end, they go through quite a bit of processing in terms of stabilization, and quite a bit of work is done on the videos using FLIR proprietary software packages. That way we can overlay multiple different palettes, different filters to magnify the emission. For instance, high sequence mode and FLIR and things like that. So
I just want to interrupt just for one quick second. This is excellent stuff, Bog. Thank you. But I wanted to just make a quick point that, as you can see here, the track log that Bog is showing you with the FLIR video overlays the same track log that Bog showed with the color video. And that's one of the advantages with our surveys is these videos are synchronized. So you have a track log basically with 2 or 3 different types of video, 2 color videos and an infrared video. And so what that allows our customers to do, or the benefit to our customers, is you can flip back and forth between the IR video and the color video when you're looking for problem areas.
Right, so I'm just going to go ahead and switch to pretty much our reporting side of things. So I'm just going to go ahead and switch to pretty much how we report our findings. So in this case, what we have is just a sample ABC energy report. So just the name of the sort of the operator, who is it prepared for, prepared by, the date. So basically in the first paragraph of the report, we'll just go over any sort of suspicious activity, if there's any, and just sort of identify them. We classify our classification points and concentration points based on 3 different classes, 1, 2, and 3. Sort of 1 is your, high concentration reading, in the order of, depending, 500 or so. 2 and 3 are sort of lesser than that. 3 is more or less when you got nothing going on, where you have pretty much nothing but ambient concentration readings. So in this case, we pretty much can identify that PPM was at 1.63. We specifically pinpoint where that specific emission came from in terms of lat and long, so the operator can go ahead and look it up on the map or use the QR code capability to send that information to the ground crew so they can address the problem. We also were asked a few times by our operators to include also color photo of the point of interest. The reason why is because operators tend to know where things are on their right-of-way, and then one simple picture can explain heaps in terms of where to look, where to find the emission. And then pretty much in the body of the report, we talk about essentially our findings in terms of presentation. So when all our information gets presented in KML and KMZ files. We also provide shape files if the customer really wants that. It just so happened that a lot of customers that are using our services are using Google Earth. So it's easier for us to just export everything in KML and KMZ. But here you can see that we reference a handful of KML's sort of raw data that also provides the heading of the helicopter, classification points based on sort of your point sources. We also do the same thing for grid classification, where the information is provided based on grids and average per grid basis, so you can see information for every single grid that you fly. And then we also sort of export our raw readings into CSV file if anyone wants to open it up, Excel spreadsheet or whatnot. Here also you can see that we provide basic information about the data, the behavior of that, temperature, humidity, air pressure, and as well as concentration. And then at the end we just provide sort of basic understanding in terms of the statistical analysis of the data. So mean for temperature, humidity, air pressure, median, standard deviation, and maximum. A lot of cases our clients are interested in wind speed, temperatures, just to kind of understand if we fall under available and sort of capabilities of the hardware that we use. Just like we mentioned, there is certain limitation in terms of speed, certain limitation in terms of above ground levels and things like that. So what I'm going to switch to next is what those KMLs that we reference in the report look like. So basically what you're looking at is our aerial patrol. So in this case, we were flying control and traverse pattern. You can see how tightly coupled the points are on the ground. In this case, you can see green, yellow, and red classification. So green points. So here you can see how we fly and how the pattern that we fly in terms of, as well as how the classification gets done. So in this case, you have a perfect example of yellow, red, and clustering. So in green, clustering represents ambient level of methane concentration. So anywhere from 1 ppm to 2 ppm is considered ambient for this specific region. In yellow, you have points of interest in terms of suspicious activity. So depending on who you essentially talk to, it will be anywhere from about 2.6 to 5 ppm is going to be your yellow cluster. In red is everything that's going to be of alarming quantity. So I believe in this cluster right here, there's a couple of points that are like 11, 12 ppm. There tend to be, okay, 5.6. Well, basically the way we are approaching our classification algorithm is there is no set thresholds, and we are using the power of machine learning, quadratic discriminant analysis, as well as Fourier transformation to give us energy information about each of these points, and then based on k-neighboring algorithm, the neighbors tend to vote for whatever is the highest point, and that's how the highest points get reflected on the map. So you can see in this case it's 10.7 ppm. All of these points are also sort of thematically represented, meaning the higher the ppm, the higher the point is going to be above the ground, providing the idea of sort of your gradual ascents, gradual descents here. In this case, you can see we were flying control and traverse pattern, meaning that we were really close between the directional sort of flying pattern, and the distance from one line to another is about 10 meters. That way we pretty much don't miss anything when it comes to concentration and methane emissions. So this is sort of an example of how we fly, how we classify the data. Now, the interesting side of things are coming into play where we're trying to superimpose the information to find the points of leakage. So in this example right here, we extracted all the yellow and red clusters. We applied wind direction and wind speed for every single of these points. You can see it here represented by purple arrows. Wind direction is indicated by degrees. Wind speed is indicated by meters per second. And then pretty much what we do next is we apply atmospheric information to the ground level to predict where the source is. Obviously, I'm simplifying things quite a bit. But in this case, you can see that this cloud of clustered points came from the points on this well pad. I don't think it's a well pad, I think it's a processing plant, but you can see that it's all the infrastructure, as well as if you were to plot the pipeline information, these green push pins will be tracing the pipeline. So you can see that the source is not only coming from the pipeline, but they're also coming from the well pads. So we have a pretty good accuracy on our source finding algorithm. It comes down to about plus or minus 5 feet. So we can really pinpoint the compressor, if there are multiple compressors in the well pad, or specific pipeline segment. So this will pretty much wrap it up as far as the webinar for today. I'm going to go ahead and switch to questions that you guys have been posting. I hope this gives you a bit of an idea of what we do and how we do things. So if you have any questions, please follow up with us via email or phone. So let's switch to questions again. Let me bring it up. Okay, why can't you fly faster? Does the Boreal sensor now work on the higher speeds? Yes, essentially the cutoff of the speed in terms of the aerial patrol is about 60 miles an hour. We're trying to keep it a little bit under just to make sure we get good data. We fly anywhere from 40 to about 55 miles an hour. What's the cost of a complete pipeline system mounted on the ground vehicle car?
That depends on a lot of different factors, and if you send us an email to my email, brian@redhensystems.com, let us know kind of what all components you're looking for, and we can certainly shoot you a price back quick on equipment or on a rental. So just a lot of different moving parts there. What threshold concentration do you normally use from the sensor in the helicopter? For example, would 50 ppm above baseline be detected, or a threshold is 0.2 ppm or 1 ppm above baseline? Oh, ppb, sorry, 50 parts per billion. Sorry, Azar, that's a great question. Bog, what do you think?
Above the baseline, the trick here is we're not really focusing on the baseline or whatnot. We're focusing on the energy aspect of the reading, meaning that it can be as small as, like you mentioned, 50 ppb or 0.2 ppm, and still, if you have quite a bit of frequency in terms of that reading, and quite a bit of oscillation, a small difference of 50 ppb can be something of interest to us, because for what we've seen, it's not just high reading, it's also the behavior of the data. Sometimes you have a pinhole size emitter that can, will not register as a high ppm, but you can still determine where the source of that was and what kind of source it was based on the behavior of the concentration.
So the next question is, do methane molecules, and this is from Carl, and I think he's clarifying an earlier question that I didn't understand. Do methane molecules enter the Boreal instrument? And that's an excellent follow-up question. Apologize for the misunderstanding earlier. Yes, they do. And basically what the Boreal is doing is it has a sample of methane in the Boreal that it's measuring the air against. And so the molecules enter the instrument, and then it's comparing that air to the sample that it has, and that's where it's making the determination on the ppm value that it's reading.
Yeah, so basically with air comes in your methane or any other fugitive gas particles, and they go through the cell, and then the laser goes through the cell, pretty much just opposing the regular information in terms of the signal versus the information that's in your cell, and based on those two differences, you get your reading. So obviously that happens quite a bit in terms of 1 second time period. I believe in our case we set it for 300 samples a second. So at the end you get an average value that's very high accuracy.
So has Red Hen Systems been utilized in academic studies? That's a question from Kendall.
Oh, yes.
The answer is yes. We've done work with the National Energy Technology Laboratory, which is a part of the Department of Energy. We've done work with NOAA and some other folks, and we're in the process of working with some other academics as well.
Right. So, the research community always comes up with the things that are cutting edge, and we're also trying to add to the process by providing our expertise as our value in terms of flying aerial and ground-based patrols. So we're always collaborating with CSU, NOAA, NATL, Department of Transportation to come up with latest and greatest sort of standard operating procedures for these kind of patrols and surveys.
So Adam asked, at what level of detail can you do source identification from the flights? Is it at the level of the site, a major piece of equipment on the site, or a minor component of the site? Well, I mean, Adam, you know, what we're doing is we're using the atmospheric data and the PPM data to make a best guess of origination. And what Bob was just showing was how we do that through our gas analyzer piece. We can get pretty close. We can get closer than just flying over the corridor. Is it exactly precisely where it is? Probably not. That would take ground verification, but it narrows the window quite a bit for our customers.
Well, basically, there is no guessing. There's quite a bit of science in terms of intersections, in terms of different kinds of filtering information and you know, stimulating the signal and things like that. As far as the accuracy goes, we've seen anywhere from 3 to 5 feet, meaning that, you know, a small compressor that's buried in other pieces of infrastructure can be identified pretty easily. I was able to identify the methanol, you know, containers with that kind of accuracy as well, which were mounted to the fence of the well pad. So things, it's pretty accurate. Just like I said, 3 to 5 feet of air, plus or minus 3 to 5 feet.
So Kendall asked, is there any effort underway to get your system approved for Colorado Regulation 7 compliance? If there is, I'm not aware of it, so I'm just going to say the short answer is no. I mean, what I tell folks is we can't guarantee that by doing our survey you're going to be compliant, but what we can do is give you a lot of information that can help you to deal with compliance and to be compliant. And the way that we do that is, you know, just what we're showing, finding these emission points so that our customers can go out and deal with them.
We usually work with sort of your method 21, you know, Quad O, subpart W, things like that. So as far as making it, you know, undergo certain procedure for Colorado, it's pretty rigorous process.
So we've got one final question from Azure. The Boreal, if it's an open path laser, his assumption is the gas doesn't go inside. So I'm just going to leave that to Bob to answer the question about more in depth of how the Boreal works.
Well, you are right, Azure. There are a couple of different modifications of Boreal equipment. What we use is Gas Finder AB, which is exactly correct. It's open path sensor. But basically what happens is that as you fly, you are willingly or unwillingly essentially sampling the air mass that you're going through. So essentially what you have is your CH4, CO2, or whatever the gas of interest is, will penetrate through the cell. By cell I mean the piece of equipment that gets mounted on at the bottom of the helicopter, at the belly. So you will get essentially your gas will pass through the cell, and the infrastructure that's inside of the cell, in terms of refracting mirrors and laser sort of activity, will pick that up and essentially register that through by providing the concentration information. So essentially, yes, the gas will sort of travel through the path inside of the cell.
So with that, we appreciate everyone attending our webinar. We do have for the helicopter pilots that are out there and the other folks who are interested in purchasing sensor equipment, specifically the Boreal Gas Finder AB that Bob was just talking about. We are doing another webinar, and it's going to be on May 24th at 11 a.m. Mountain Daylight Time, and it is going to be focused on how to use a Boreal. So it's a little bit different topic, and it's for maybe a little bit different audience, but we just wanted to bring that to your attention. If you have any questions about the pipe-by service, you can email me at Brian, B-R-I-A-N, at redhensystems.com, or Bog, B-O-G, at redhensystems.com. Please feel free to do that. We thank you for your time, and we hope you have a great day.